Hello students, welcome back to Atul Academy. Now this video we will be learning about the electron dot structure, its carbon and compound part 2. Part 1 we studied about the properties of carbon, how it is able to make so many compounds. So I hope that is clear to you. You have gone through the video, you have gone through the notes and your NCERT book also very well. Now let us talk about the electron dot structure. What is this electron dot structure? Basically this structure will tell you how the different type of bonds are being made. We have single bond, double bond, triple bond. So how those bonds are being made by sharing of electrons in with within the compound or molecule. Let us talk about that. So we'll start with first molecule, that's hydrogen molecule. Hydrogen, we know atomic number is 1. So its electronic configuration is also 1. So it is not stable. It needs one more electron to complete its octave. So sorry, not octet. It's K shell only, which only need two electrons. So how will it do that thing? So hydrogen has only one electron. You can represent the electron either with X or you can represent it with dot. It's your choice, whatever you want. Another thing, when you have two elements, you need to differentiate between them. Suppose if it is hydrogen, we'll take X, oxygen, we'll take dot, so that we differentiate between the electrons of both of them. This is when you have two elements which are sharing electrons, but in case of one, you can use only one symbol only. So let us do it now. Hydrogen has one electron only. So how will it complete it? If it takes one more hydrogen, takes one electron of that. So if you see, this hydrogen will take this hydrogen is also going to take this. So both the hydrogens are sharing their electrons. So we have a single bond over here, which is represented by a single line. So here only single covalent bond is being formed between two hydrogen atom, and it is a covalent compound molecule. Let's take another example, oxygen molecule. Oxygen, atomic number 8, electronic configuration 2, 6. So it has 6 electrons in the outermost shell. Oxygen 1, 2, 3, 4, 5, 6. I have to take another oxygen because O2 molecule has 2 oxygen atoms. So like this. Now this oxygen has 6, it needs 2 more, so it will share it with this oxygen. This oxygen is also going to share with this one. Now what type of bond I have? I have double bond because two pair of electrons are being shared. So we have a double bond in oxygen molecule. Now nitrogen molecule, let us say nitrogen atomic number is 7. So its electronic configuration is 2, 5. So it has 5 electrons in its outermost shell. So nitrogen has 5 electrons. So let me represent it like that. Again nitrogen is like this. So this nitrogen has 5 electrons in the outermost shell. This also has 5, so but it needs 3 more. So it will take these 3. It will take these 3. This nitrogen will also take these 3. So if you see, we have 3 pair of electrons being shared. So we have, which we represent by 3 lines, that becomes triple bond. So N2 molecule has triple bond. This is how the electron dot structure of hydrogen, oxygen, nitrogen molecule. We can also discuss about chlorine. So chlorine, if we know, the electronic configuration, it has atomic number 17. Our electronic configuration is 287. It has 7 electrons in the outermost shell. So I'll try to draw it over here. So chlorine has 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7. Another chlorine also 1, 2, 3, 4, 5, 6, 7. And if I take like this chlorine has 8 electrons now. If I take like this chlorine also has 8. So you see over here we have single pair being shared. So we have only Cl2 molecule, which is single bond. Over here we are getting a single bond. So it is also a covalent bond over here in chlorine molecule. Let us talk about few more examples. Ammonia. Ammonia molecular formula is NH3. So as we all discussed in the previous slide, that nitrogen has 5 electrons in its outermost shell. it needs 3 more electrons. So when it combines with hydrogen, single hydrogen will not work because it has only 1 electron. So it needs 3 hydrogen atoms to combine with. So let us keep them over here. So 1 hydrogen will come over here, 1 hydrogen here, because it has to take 3 electrons. So 3 hydrogens will be there to combine with it. So nitrogen combines with 3 hydrogen elements to complete its octet. And if you talk about this nitrogen, it will take all these electrons, and if you count 1, 2, 3, 4, 5, 6, 7, 8, 8 are complete. So we have, this is the structure for ammonia. You can write it like this also. Let's talk about carbon dioxide. Carbon dioxide, carbon we know it has atomic number 6. So its configuration will be 2, 4. So it has 4 electrons in the outermost shell. So let us do it. So 1, 2, 3, 4. Now, if it combines with oxygen, oxygen has 6 electrons in the outermost shell. So I'll differentiate it using this. Oxygen has 6 electrons. So how will it do? It has to use 2 electrons it can share with this oxygen, 2 electrons it has to share with another oxygen also, because one oxygen will not work because it will not be able to share all 4 with these 4. So because oxygen will be imbalanced then. So we will have to work out over this. So let's say carbon has 2 electrons, 4 electrons in the outermost shell. So it will share 2 with this oxygen element, and it will share 2 with this one. So if we see over here, the oxygen got 8, this oxygen also got 8, and carbon total will also have 8. So we have double bond. How double bond is being formed? We see 2 pair of electrons are being formed over here. We see 2 pair of electrons are being formed over here. So in carbon dioxide, there is a double bond between carbon and oxygen while sharing the electrons. So this was electron dot structure of carbon dioxide. Let us move to another one. Let's talk about methane. Methane is the simplest hydrocarbon. Hydrocarbon are the compounds of only carbon and hydrogen. It is also used as a fuel and is a major component of biogas and CNG. So CH4. So carbon we all know has 4 electrons in the outermost shell. These 4 electrons cannot be satisfied by one hydrogen because one hydrogen has only one, so it needs 4 hydrogen atoms to be combined over here. So now this hydrogen will share this hydrogen will share this hydrogen will share this, and carbon will share all 4 from all 4 hydrogen. This is the electron dot structure of methane. Water, let's talk about water. So water, hydrogen again has only one electron. Hydrogen again has only one electron. Oxygen has 6 electrons. Oxygen has, I'll differentiate it because there are 2 different elements. So I'll keep it as dot for oxygen. Let's say 1 over here, 1 over here, 4, 5, 6. Now this hydrogen will take this electron, this hydrogen will take this, and oxygen will take from over here. So I say only one, see, I see only one pair of electron being shared. So oxygen makes single bond with 2 hydrogen atoms. So we have H2O as compound, covalent compound with only single bond. No double bonds are over there. In methane also you have single bond. One more example is there for sulfur molecule. Sulfur is in the same group as of oxygen. So its atomic number is 16 and its electronic configuration KLM will be 2, 8 and 6. So it also has 6 elements as of, sorry, 6 electrons as carbon in its outermost shell. So I can represent it as like this: 1, 2, 3, 4, 5, 6. I'll keep it as dot because we need to make a ring, because sulfur, 8 molecules combine in sulfur to make the sulfur molecule. 8 elements, sorry, combine in sulfur to make the sulfur molecule. So we will arrange them in this form. There is a crown shape also, you can, but it's easy to make the ring form, so we will do like that. So sulfur, sulfur, let me first arrange all of them like this: sulfur, sulfur, one more sulfur, sulfur. Total there are 8 sulfur elements. Let's just put them: 1, 2, 3, 4, 5, 6. This one has this: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again 1, 2, 3, 4, 5, 6. 4, 5, 6. 1, 2, 3, 4, 5, 6. So this one also: 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So let us see how they will be combining. So this one let's start with. This needs, it has got all 8. Yeah. Now this one has got all 8. Let's talk about this one. It has 6, so it needs 2 more. So it will take from this. It is done. All 8 are there. Now if I talk about this one, I think this one will take these 2, and that is being done. I think I did it in a wrong way. Let me erase it and redo it, because this will not going to work. Let me just redraw it, because it is not going giving a symmetrical figure. So let us just redraw it once more. I'll again keep a little space. S, 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 S. So 1, 2, 3, 4, 5, 6. It is for this one. Then it's 1, 2, 3, 4, and 5, 6. Same way: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think if we go in the same manner: 1, 2, 3, 4, 5, 6. All done. Now let us start making the pair. So this one is 1, 2, 3, 4, 5, 6. So this one will make a, we have to take these 2 from over here: 1, 2, 3, 4. Again it is a little bigger. So this is done. Now this one will take 2 electrons from over here. So one pair sharing done. This will also take these 2. So one more sharing done. This will also take these 2. One more pair of share. This will also take 2. So there is one more over here. This one will take these 2, and again over here. So one more pairing over here. This one will take these 2. So all 8. Now this one, this is a single only: 1, 1, 2, 3, 4, 5, 6. Yes, 6, and 2 these. So we have this type of structure of sulfur. I hope this is clear. So we have it is all single pair sharing, so we have single bonds only over here. Now let us talk about ethane and ethene. Ethane is a hydrocarbon again. So you will learn about these molecular formula and what is this ethane in the next video. But to tell the electron dot structure of this, let's just say carbon again has 4 electrons. Ethane has 2 carbons. So first let us make it. 2 carbons are there. Simple structure I'm making. 2 carbon are there. So this carbon will share its electrons with 3 hydrogen. This carbon also will share with 3, because it is sharing with this carbon. So that is it. So let us change it into electron dot structure. So how will it be? Carbon has 4 electrons in the outermost shell. This carbon also has 4 electrons in the outermost shell. Hydrogen will be like this. Dot I'll take. And when I combine, hydrogens will take these things, these electrons like that. And carbon, this carbon will take 1, 6, and this is 7 and 8. Similarly, this carbon will take so total 8. This is electron dot structure of ethane. I hope it is clear. Now let's talk about ethene. Ethene has double bond between the carbon atoms. Ethene structure is like that. So if you see, two pair of electrons are shared over here. So two pair electron done, only two are left. So it has one hydrogen here. Two for this are left, so only two hydrogens over here. So let us convert it into electron dot structure. So carbons together with each other, they share two electrons, and over here we will have hydrogen. So over here we will have hydrogens. So carbon, if I check this carbon, if we see 4 electrons over here and 4 electrons over here. This carbon also same way, 4 electrons here inside, 4 electrons over here total. Hydrogen only 2 electrons done, hydrogen 2 electrons done, hydrogen 2 electrons, this hydrogen also 2 electrons. So we have double bond C. I can also write it at like this, or you can say CH2 double bond CH2, and this one I can write as CH3 single bond CH3. So these are the electron dot structure of ethane and ethene. You can draw as many as electron dot structure for propane, propene, propyne, ethyne also is there. So that we will do later on, and you can practice it on your own also. So I hope the electron dot structure is clear to you all. Thank you for watching the video, and in the next video we'll learn about hydrocarbons, nomenclature, functional groups. Thank you very much.